Hello, my name is Hunter Houston, and this is my protocol presentation for Dr. Gwynn's Network Systems course. I have chosen to do my presentation over TCP, or the Transmission Control Protocol. First, I'm going to go over what TCP is. So, TCP, or the Transmission Control Protocol, is a transport layer protocol in the OSI model that is used to create a connection between computers by transporting and ensuring the delivery of messages over supporting networks. So, to put that more basically, TCP is an important network protocol and it's designed to send data packets over the internet and ensure that they arrive in the same order and the same way that the sender intended them to. TCP is definitely a very important protocol, if not the most important protocol, and I'm going to get into why in just a minute. Next, I want to talk about TCP IP. So, TCP works together with IP, or Internet Protocol, in a well-known duo called TCP IP, or the TCP suite. And TCP works in collaboration with Internet Protocol, where TCP ensures end-to-end delivery of data between distinct nodes, which nodes are basically, to put it simply, devices within a network, as well as transports and ensures that data is delivered to the correct destination. That's the basis of TCC. And IP defines the logical location of a remote node or device. So they work together in that way, and they're very commonly grouped together. And TCP transmission of data on a network is done in layers, with each protocol in one layer doing something complementary with what the others are doing. And this set of layers is called the protocol stack. And TCP and IP work hand in hand in the stack, one above the other. So TCP and IP are very commonly put together. They're two peas in a pod, and you'll commonly see them grouped together. The TCP IP suite, or also known as the Internet Protocol Suite, is also similar to the OSI model in the sense that it has layers, except the Internet Protocol Suite precedes the OSI model. It only has 4 layers. It has the application, transport, internet, and linked layer, where the OSI model actually has 7 layers. The application, presentation, session, transport, network, data link, and physical layers. Now getting into the meat of what TCP actually does. So the function of TCP is to control the transfer of data in a way that it's reliable. So on networks like the internet, data is transmitted in packets, and packets are basically units of data that are sent independently on the network, and once they arrive at their destination, they're reassembled in order to give back the original data. And so TCP is therefore responsible for ensuring reliability during transmission. That's the main job of TCP. It ensures that the data arrives in the way that it was intended to be upon arrival. This is, as I was talking about earlier, why TCP is a very important protocol and how it affects everyone that uses the internet's lives in ways that you might not even expect. So here is really what TCP does. This is what it affects everyone, and it is the nitty-gritty of how TCP works. So TCP, first off, ensures that all the packets that are sent reach their destination and that no packet is lost. For example, one doesn't want their letters or sentences missing when you send your email or instant message. Otherwise, when it reaches the recipient, it would just be loose words not making any sense, and you'd have a message that would be unreadable. So that's one big job of TCP, is making sure that your packet is never lost, that it always reaches its destination. And then TCP also ensures, secondly, that there is no delay that would affect data quality. So you wouldn't want your conversation during your VoIP, your voice over IP call, and when you're streaming audio to be consistent. And if that fails, it will result in your words being unrecognizable. So basically what would happen is you'd be talking, and the other person wouldn't be able to understand a thing that you're trying to say, because that TCP comes in and makes sure that that does not happen and that your voice is able to be heard. Thirdly, TCP ensures that all the data packets that are sent are reassembled in order, because you don't want your words and your sentences or your email to be in the order you wrote. Or you want your words and your sentences or your email to be in the order you wrote them. So when you send your email, you want the recipient to receive the email and be able to read it in the way that it was intended to be written. You don't want them to open their email and the words be all out of order, because they might be able to make it out, but it's going to be hard for them, and TCP ensures that everything works out in the way that it's supposed to work out. TCP is very important, and it ensures everything that the sender intended for the packet to be as when it arrived is as such. So next I want to get into how TCP works. So how TCP works is TCP labels its packets so that they're numbered, and it also makes sure that they have a deadline to reach their destination. So for each packet that is received, the sending device is notified through a packet called acknowledgement. So whenever you send a package out, when the other device receives the packet, it sends another packet back that acknowledges the reciprocation of the packet. And so, yeah, the name says it all. If after the timeout and no acknowledgement is received, the source also sends another copy of the missing or delayed packet. So if TCP detects that it's either taking too long or the packet has not been received, it will just go ahead and resend it. That's the good thing about TCP. It ensures that the packet arrives and arrives in the way that it was intended to be. And so out of order packets are also not acknowledged. So if the sender sends out a packet and it is received out of order, then TCP just takes that as a resend. So TCP covers all those areas. And so this way, all the packets are always assembled in order without holes and within a predetermined and acceptable delay. So TCP is all about ensuring and making sure that the sender is able to send a packet and the recipient receive it in the way that the sender intended. That's all that TCP is about. And without it, we would just have jumbled emails, unrecognizable emails. It would be a pain. So TCP comes in and makes sure everything works out. Next, I want to talk about TCP addressing. So while IP has a complete mechanism for addressing known as IP addressing, TCP has no such elaborate addressing system. It actually doesn't need one. So it only uses numbers provided by the device it's working on to identify where it is receiving and sending packets and for which service. And these numbers are called ports. So for example, web browsers use port 80 for TCP and port 25 is used for email. And the port number is often coupled with IP address for a service. So that's TCP addressing. The fact is, it just doesn't have an elaborate addressing system like IP. It just has numbers called ports. So next I want to talk about the difference between TCP and UDP. They are similar as they're both in the transport layer. However, there is some distinct differences. So TCP guarantees that the recipient will receive the packets in order by numbering them. And then the recipient sends messages back to the sender saying that it received the messages. As I talked about earlier, those are acknowledgement packets that it sends back. And if the sender doesn't get the correct response that it's looking for, or it senses that it's been delayed or the packet hasn't arrived, it will resend the packets to ensure that the recipient received them. It ensures that in TCP. TCP is all about ensuring delivery and in the way that it was intended to be delivered. And so packets are also checked for errors in TCP. It does all the error checking. It makes sure that there's nothing wrong, nothing out of place. It is a very reliable protocol that ensures all that. And TCP is all about this reliability. However, with UDP, packets are just sent to the recipient. So when using UDP, there is no error checking. There is no going through and making sure that the packet has arrived successfully and in order. It just sends it. And the sender will not wait to make sure the recipient received the packet. It will just continue sending the next packet. It doesn't care. So if you're the recipient and you miss some UDP packets, then too bad. It's gone. So that's the main difference between TCP and UDP in that department, is that TCP does error checking and reliability, and UDP just sends it regardless. So to wrap up, I'm going to go over the key points of TCP. So TCP, the main things that need to be known are that TCP controls the transfer of data so that it is reliable. TCP is all about reliability. TCP performs error checking and makes sure that the packets arrived in the way that the sender intended. And it will resend if they were not. And then TCP works together with IP in the TCP IP suite, a very common thing you will see. And TCP labels its packets so that they are numbered. Like I talked about this in addressing. There's no elaborate addressing system. TCP just labels its packets so that it can track them and perform error tracking. And then lastly, the main things TCP does, to round up, are it ensures that all packets reach their destination. It ensures that there is no, and also ensures that there is no such delay that would affect data quality, and that it ensures that all data packets are reassembled in order. So TCP makes sure that the packets that are being sent out arrive in the way that they were meant to arrive. And that pretty much sums up what TCP is, and that is my presentation.